Hello everyone, today we have a very big day. We are going to be learning how to factor a polynomial, and we're going to be using the box method. Since everybody was doing really well with the box so far, when we were multiplying, we're going to be factoring using the box as well. Factoring is an extremely important thing that you're going to need for this entire chapter. It's going to be all about factoring. It's also going to be something that you're going to need in the next chapter, and the next chapter, and for all of high school math. So factoring is a huge topic, and it's something that you're just going to need to learn how to do. So it's one of those things, it's kind of like long division, where it's just something, you need to learn at some point. So what is factoring? So factoring is figuring out which two factors multiply to an expression. So, like if you wanted to factor the number 8, you could say, oh, if I factor that, it's 4 times 2. And we've already done stuff like that. That's just one factor pair of 8. But when we use the box, we're figuring out the outside of the box, right? So if we have an area of 8, what are the outsides? That's the actual answer. And 2 and 4, that's my answer. Now we're going to do that with polynomials. So first we're going to start off with a problem that you guys have seen before. You've done a bunch of these types of problems. And really, all we need to do is, we're just looking at this, and we need to factor this expression. And what we're going to do is we're going to just put our terms in these boxes. 12n cubed, negative 15n squared, negative 8n, and then positive 10. And then what I usually do is I usually start with figuring out what this spot is first. What goes there? And you just look at the two multiplications that it's involved in. It's involved in this 12n cubed, and it's involved in this negative 15n squared. So n cubed and n squared, those have a GCF of n squared, so I can get an n squared from there. And then 12 and negative 15, I can find a factor of 3. That's their greatest common factor. Now that we know that this is 3n squared, this just becomes like a little puzzle, almost like a Sudoku puzzle. 3n squared times what up here gives me 12n cubed? That's going to be 4n. Because 4n times 3n squared gives me that 12n cubed. And then maybe let's look down here now. What times 4n gives me negative 8n? That would be negative 2. And then we can look up here. We need a number up here that you can check two different spaces. Negative 2 times what gives you 10, or what times 3n squared gives you negative 15n squared. And that would be negative 5, just negative 5, yeah. That's all we need. We can check. Negative 5 times 3n squared gives me negative 15n squared. Negative 5 times negative 2 gives me 10. So then we just need to write our answer. Our answer is right here. 4n minus 5, parentheses, times this right here, 3n squared minus 2. And that's my actual answer. This multiplied equals this thing right here. And that's what we were trying to do. We're trying to break it up into two factors that we can multiply. So it's very easy when you have 4 terms. You just stick them in the boxes, you figure out what the outside is. Now look at this one. What do you think is so hard about this problem? So we can look at this problem and we could start figuring it out. 3x squared, we're always going to put our biggest term in the top left-hand box. Our 4 can go in the bottom right box, our smallest term sort of goes in that bottom right box. But then now we have some trouble here. We've got 7x and it's got 2 boxes to go in, so we're going to need to split it up somehow. But how do we split it up? Well, there's only one way that's going to work. So you could split it up into, let's just try 6x and x. Let's try that. So if I try that, watch what's going to happen. I get 3x squared and 6x, so this is going to be 3x, that's the GCF. And then this would have to be x. This would have to be 1, because x times 1 gives me x. And now look at this. 3x times 2 gives me 6x, but 1 times 2 does not give me 4. So this whole thing got messed up because of these two red boxes that I put. Maybe let me try something else. Maybe I could split up 7x a bunch of different ways. I could try 5x and 2x. And I hope you guys can see that that is also not going to work if you kept trying it. What is going to work, and I'm not going to tell you why quite yet, but what is going to work is 3x and 4. It's kind of a weird one because it's exactly the same as, 3x and 4. It's exactly the same as these other two numbers, but let's just check out what's going to happen. So this row, we can factor out a 3x, which would make this an x, and then this is x times what gives me 4x? That would be 4, and then 4 times 1 gives me 3x, and that's 3x right there. 3x times 1 gives me 3x, so everything's good. So now we have our answer, x plus 1 times 3x plus 4. That is my answer. Now the mystery is, how did I know to make those two boxes what they are? It's just a coincidence that these two boxes are both 3 and 4. That's a little bit of a coincidence. What I want to point out, though, is 3x squared times 4 is 12x squared. And 3x times 4x is also 12x squared. That will always be true. Whenever you multiply the diagonal boxes, they will always multiply to the same thing. That is the most crucial thing that we're going to learn today, and I just summarized it on this slide right here. So how do we split up that middle term? I want you to make sure that you have this written down. This is really, really important. So those two green boxes, two green boxes will always add up to the middle term. They're going to add to the middle term. And they're going to multiply to the same thing the other two boxes multiply to. So write that down, and we're going to do an example. Okay, so on this problem, we have, again, fill out the easy boxes first, x squared and 5. And then now this 6x has to be split between those two boxes right here. There's a lot of ways to do that, right? 5x and 1x, 4x and 2x, 3x and 3x. There's only one way that's going to work, though. And I don't really want you to just try stuff until it works, because some numbers might be a lot bigger than 6. What we know is that whatever those two boxes are, they're going to add to 6x. That's obvious, right? They add to the middle term. And they need to multiply to the same thing that these two numbers multiply to, which is going to be 5 times x squared. Now here's where you just have to think. 5x squared, it multiplies to 5x squared but adds to 6x. So think about your factor pairs of 5x squared. What times what? Probably the easiest one to think of would be 5x times x, because that multiplies to 5x squared. And what's 5x plus x? Also 6x. So these are the right things. So now we're going to plug these in, these two terms, we're going to plug them in here, 5x and x. Now all that's left to do is to figure out the outside, which is kind of the easy part, right? The only way to get x squared would be x times x, and then x times 5 is going to give me my 5x, and then 5 times 1 is going to give me that 5, or x times 1 is going to give me that x. So now I have my answer, x plus 5 times x plus 1. Boom. All right, let's try another example. Actually, I'm going to show you guys the complete set of directions. If you like steps, if you like kind of remembering steps and doing things that way, go ahead and write this down. These are the steps to factor a trinomial. This will work for anything. It's kind of a long process. You'll notice that these problems are not short. You're not going to be able to do them in your head. You have to always draw a box. You have to always draw an X. And then you're figuring out what the outside of the boxes are. All right, best way to learn is through these examples. So let's look at another example here. 2x squared goes right there. Negative 2 goes right there. Now, this is the important term. We need to figure out how to split this middle term such that it adds to negative 3x, but multiplies to the same thing that the other two boxes multiply to. So 2x squared times negative 2 is going to be negative 4x squared. So can you think of two numbers that multiply to negative 4x squared but add to negative 3x? It's going to be x and x for sure, because x times x gives you that x squared, and x plus x gives you 2x's. So now you only have to deal with the numbers. What multiplies to negative 4 but adds to negative 3? Here's where sometimes it just takes a while. What multiplies to negative 4 but adds to negative 3? Let's try. Well, 4 times negative 1, that multiplies to negative 4. But you'll see that adds to positive 3. So that's not right. What about negative 4 times positive 1? That multiplies to negative 4. And it adds to negative 3. So that must be right. So we get negative 4 and 1. So now we're just going to plug those in there. Once you've got this, you're pretty much home free. Negative 4x and 1x. Now that we've got the inside of our box filled out, figuring out the outside is not very difficult. We need to figure out what the GCF maybe here is. So 2x squared and negative 4x. So they both have a 2 in them, because 2 and 4. And they both have an x in them, because x squared and x. So 2x goes there. Now we just bounce around and we figure out the rest of the outside. So 2x times x gives me that 2x squared. X times 1 gives me that 1x. And then 1 times negative 2 gives me that negative 2. So now we just need to make sure we write our answer. Our answer is going to be x minus 2 times 2x plus 1. Boom. All right, let's look at another example. 4x squared plus 9x plus 2. So again, 4x squared goes here. That's your big boy. 2, the small guy, goes in the bottom right. So we got those taken care of. Now this middle term has to be split. This 9x has to be split between these two boxes such that they add to 9x but multiply to the same thing that these multiply to. So they multiply to 8x squared. So I want you guys to think, what is going to multiply to 8x squared but add to 9x? Just think about it. What multiplies to 8x squared but adds to 9x? Let me try. So 8x squared, that's going to be x times x, obviously. But what multiplies to 8 but adds to 9? That's just going to be 8 and 1. All right, we got it. 8x times 1x. If you multiply those, 8x squared. If you add them, 9x. So let's throw those in there. Doesn't matter which box you put them in, by the way. And then now that we have that, very simple to figure out the outside of our box. 4x squared and 8x, find the GCF there. That's 2, no, not 2. 4 and 8 have a GCF of 4, and x squared and x have a GCF of x. 4x times x gives me 4x squared. X times 1 gives me 1x. And then 1 times 2 gives me 2. And there's our answer. Our answer is on the outside. It is x plus 2 and 4x plus 1. Boom. One more example. So 5x squared plus 13x plus 6. So again, 5x squared goes there, 6 goes there. We need to split this 13x into these two boxes such that it adds to 13x, but multiplies to the same thing that these multiply to. These multiply to 30x squared. So now you just need to think, what multiplies to 30x squared but adds to 13x? That's going to be, well, 30, we could do 6 times 5, right? 6x times 5x, but that's going to add to only 11x, so that's close, but it's not right. What about 3x times 10x? There we go. 3x times 10x, that adds to 13x. 3x, 10x, boom. And now you just throw them in there. 3x, 10x, doesn't matter which one. And now we'll just figure out the outside. So 5x squared and 10x is going to be 5x. And then 5x times x gives me 5x squared. X times 3 gives me 3x. And then 3 times 2 gives me that 6. You could also double check. 5x times 2 gives me 10x. Now we just need to make sure we write our answer. We get x plus 2 times 5x plus 3, and that is a fully factored polynomial. So I know this is a lot of steps, I know it's a lot of work, and you need to get used to, you will not be able to do this in your head. So I'll leave up these steps on the screen, so I want you to make sure you get those in your notebook. And then I want you to start working on your assignment today. It's going to take a lot of practice. We're going to keep practicing this next week as well. Have a fantastic day.